So in this class, let us discuss about 2 by 1 multiplexer. So two inputs and two inputs and one output. This is nothing but a 2 by 1 multiplexer. Okay, na? It's 2 by 1. So first number indicates the input, second number indicates the output. Okay, na? Right. So for 2 by 1 multiplexer, we need two inputs D0 and D1 and one output Y and one selection line, because 2 to the power of 1 into 1 equal to 2 by 1, no? So power, this power will give us number of selection lines are required for a multiplexer. So here this is a single selection line and there is another E pin, enable pin. So this 2 by 1 multimux will be enabled. Okay, now first is what is a multiplexer. So first let us know many inputs and single output. Many inputs and single output. It may be 2 by 1 multiplexer, 4 by 1 multiplexer, 8 by 1 multiplexer, 16 by multiplexer, 32 by multiplexer. So always single output. Input may vary in between 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4 and 2 to the power of 5. So 2 for 1 means single selection line required. If you are going 4 by 1, so 2 selection lines required. If you are going 8 by 1 multiplexer, 3 selection lines. 16 by 1 multiplexer, 4. 32 means 5 by 1, 5 selection lines are required. Okay. Right. So it is a D0, D1 are the inputs. So selection line, based on selection line, input will be passed to the output side and there's enable pin power of this, and always multiplexer will give us single output. Okay, na? So let us discuss about the truth table. So here selection line is one of the input selection line, and there is another pin is enable line, and there is a output y. Okay, y is the output. So if the enable line is disabled, so either you are giving 0 or 1, 0, nothing, you won't get any output. We won't get any output. Clear, no? Next. So if enable 1 is 1, enable pin is 1, so selection line is 0. So D0 will be appear across the output side. If the selection line is 1, because enable pin must be high. If the selection line is 1, so we are going to get D1 as the output. For example, I am writing here, it is a 2 by 1 multiplexer. So D0 and D1, two inputs, and there is a single output and one selection line. Okay, now whenever you are giving selection line equal to 0, so D0 will be connected to the output. At a time only y equal to D0. At a time only one of the input is connected to the output side. So when I'm giving s equal to 1, right, when I'm giving selection line equal to 1, now so this one will be connected to the output. Okay, now at a time only D0 or D1. So when s equal to 0, D1 will be connected to the output because it is acting as a data selector. So many data input lines will come, and among many data inputs, single input will be connected to the output. Okay, na? So the output depends only on the selection line only. If the selection line is 0, D0 will be connected to the output. S equal to 1, D1 will be connected to the output. Okay, na? So it is nothing but a truth table. Okay, so now we are going to see about, so when that we have one selection line, no? So enable pin, so this is enable pin I'm writing, and s, so s bar, because s equal to 0 means s bar, s equal to means just s only, that's how I've taken this, and two inputs D0 and D1 are the input. Okay, now when I'll get this output D0, so D0 is we are going to get es bar, and whenever s equal 0 means s bar, no, s equal 0, D1 will be connected to the output. So this is a y equal to this one. Next another nothing but enable pin, and whenever you're giving 1, yes or not, yes, and whenever giving 1, D1 will be connected to the output. This is the expression. Okay, so this is done in s equal to 0, it is done in the s equal to 1. This is expression out. What is the final expression? Output y equal to e s bar D0 plus e s D1. Okay, so any one of the input So among the two inputs, so output equal to either this one or this one. So final output, you are going to single output, no? That's why I'm combining this ES bar D naught and ES D1. Okay, na? Let me design this circuit for clarity of understanding. Okay, so what is the expression just now we got? So y equal to es bar d naught plus es d1. Okay, na? So that whenever s, so this is enable and pin must be high. Enable pin must be high. Okay, na? So next one is first, whenever s equal to 0, I'm going to get d naught as output. So s bar, this is a s bar, and enable pin must be, this is nothing but programming. Okay, na? And the d naught will be connected here, so that all in between that there is a and relationship. That's why I'm connecting all together like this. Now it is es bar. Another one is what? E means this one. Okay, na? Yes, now s means, because s equal to 1 means what? D1 will be selected. Now I'm taking the D1. Okay, na? So these two are in between, there is a and relation. So I'm connecting to all the, so one of the and gate. Now what is es D1? So we have to come and plus, no, plus nothing but OR gate is required. The output is y equal to es bar d naught plus es d1. Okay, now so this is a single output because it is a 2 by 1 multiplexer now. So I'm giving two inputs, so I'm going to get output like this. Okay, now so thanks very much, thanks for watching. This is a design of 2 by 1 multiplexer.